Hello everyone. Today we'll discuss about rational numbers. Hello everyone. Today we'll discuss about rational numbers. Here's the introduction of rational numbers. You begin your study of numbers by counting objects around you. The numbers used for this purpose were called counting numbers or natural numbers. They are 1, 2, 3, 4, etc. By including 0 to natural numbers, we got the whole numbers, that is 0, 1, 2, 3, etc. The negatives of natural numbers were then put together with whole numbers to make up integers. Integers are -3, -2, -1, 0, 1, 2, 3, etc. We thus extend the number system from natural numbers to whole numbers and from whole numbers to integers. We were also introduced to fractions. These are numbers of the form numerator by denominator, where the numerator is either 0 or a positive integer and the denominator a positive integer and denominator a positive integer. We compared two fractions, found their equivalent forms and studied all the four basic operations of addition, subtraction, multiplication and division on them. In this chapter we shall extend the number system further. We shall introduce the concept of rational numbers along with their addition, subtraction, multiplication and division operations. Need for rational numbers. Earlier, we have seen how integers could be used to denote opposite situations involving numbers. For example, if the distance of 3 km to the right of a place was denoted by 3, then the distance of 5 km to the left of the same place could be denoted by -5. If profit of Rs 150 was represented by 150, then loss of Rs 100 could be written as -100. There are many situations similar to the above situations that involve fractional numbers. You can represent a distance of 750 meter above sea level as 3 by 4 kilometer. Can you represent 750 meter below sea level in kilometer? Can you denote the distance of 3 by 4 kilometer below sea level by -3 by 4? We can see -34 by is neither integer nor a fractional number. We need to extend our number system to include such numbers. Now, we have to define what are rational numbers. The word rational arises from the term ratio. We know that a ratio is like 3:2, can also be written as 3 by 2. Here 3 and 2 are natural numbers. Similarly, the ratio of two integers p and q, p is to q, can be written in the form p by q. This is the form in which rational numbers are expressed. A rational number is defined as a number that can be expressed in the form p by q, where p and q are integers and q is not equal to 0. q is not equal to 0. Thus, 4 by 5 is a rational number. Here p is equal to 4 and q is equal to 5. Is -3 by 4 also a rational number? Yes, because p is equal to -3 and q is equal to 4 are integers. You have seen many fractions like 3 by 8, 4 by 8, 1 whole, 2 by 3, etc. All fractions are rational numbers. Can you say why? How about the decimal numbers like 0.5, 2.3, etc.? Each of such numbers can be written as an ordinary fraction and hence are rational numbers. For example, 0.5, that is 5 by 10, 0.333333 by 1000, etc. Right? Numerator and denominator. In p by q, the integer p is the numerator and the integer q not equal to 0 is the denominator. Thus, in -3 by 7, the numerator is -3 and the denominator is 7. Mention 5 rational numbers, each of whose numerator is a negative integer and denominator is a positive integer. Numerator is a positive integer and denominator is a negative integer. Numerator and denominator both are negative integers and numerator and denominator both are positive integers. Are integers also rational numbers? Any integer can be thought of as a rational number. For example, the integer -5 is a rational number because you can write it as -5 by 1. The integer 0 can also be written as 0 by 2 or 0 by 7, hence it is also a rational number. Thus, rational numbers include integers and fractions. Rational numbers include integers and fractions also. Equivalent rational numbers. A rational number can be written with different numerators and denominators. For example, consider the rational number -2 by 3. -2 by 3, if we multiply both the numbers by 2, we are getting -4 by 6. We see that -2 by 3 is same as that of minus 4 by 5. Also minus 2 by 3, if we multiply with minus 5, we'll get 10 by minus 15. So minus 2 by 3 is also same as 10 by minus 15. Thus minus 2 by 3 is equal to minus 4 by 6 equal to 10 by minus 15. Such rational numbers are equal to each other are said that are equal to each other are said to be equivalent to each other. Again, 10 by minus 15 equal to minus 10 by 15. How? By multiplying the numerator and denominator of a rational number by the same non-zero integer, we obtain another rational number equivalent to the given rational numbers. This is exactly like obtaining equivalent fractions. Just as multiplication, the division of the numerator and denominator by the same non-zero integer also gives equivalent rational numbers. For example, 10 by minus 15. If we divide this by minus 5, then minus 2 by 3, right? And minus 12 by 24, if divided by 12, we get minus 1 by 2. Then we can write minus 2 by 3 as minus 2 by 3 or minus 10 by 15 as minus in between minus 10 by 15, etc. Now positive and negative rational numbers. Consider the rational number 2 by 3. Both the numerator and denominator of this number are positive integers. Such rational numbers is called positive rational integers. So 3 by 8, 5 by 7, 2 by 9, etc. positive rational numbers. The numerator minus 3 by 5 is a negative integer, whereas the denominator is a positive integer. Such a rational number is called negative rational number. Minus 5 by 7, minus 3 by 8, minus 10 by 5, etc. are negative rational numbers. Is 8 by 3 negative rational numbers? Yes, it is a negative rational numbers, right? So minus 8 by 3 is a negative rational numbers. Similarly, 5 by minus 7, 6 by minus 5, 2 by minus 9, etc. are all negative rational numbers. Note that the numerators are positive and their denominators are negative. The number 0 is neither a positive nor a negative rational number. The number 0 is neither a positive nor a negative rational number. What about minus 3 and minus 5? You see that minus 3 minus 5, if we multiply it minus 1, 3 by 5. Therefore, minus 3 by minus 5 is a positive rational number. Minus 2 by minus 5 by minus 3, etc. are all positive rational numbers, right? Which of these are negative rational numbers? This is negative rational numbers, this is negative rational numbers, and these are all positive rational numbers. Rational numbers on a line. How to represent rational numbers on a line? You know how to represent integers on a line. Here let us draw one such line. The points to the right of 0 is denoted by plus sign and are positive integers. The points to the left of 0 are denoted by minus sign and are negative integers. Representation of fractions on a number line U is also known to you. Let us see how rational numbers can be represented on a number line. Let us represent the number minus 1 by 2 on the number line. As done in the case of positive integers, the positive integers would be marked to the right of 0 and the negative rational numbers would be marked to the left of 0. To which side of 0 will you mark minus 1 by 2? Being a negative rational numbers, it would be marked to the left of 0, right? You know that while marking integers on the number line, successive integers are marked at equal intervals. Also, from 0, the pair 1 and minus 1 is equidistant. So the pairs 2 and minus 2, 3 and minus 3, right? In the same way, the rational numbers 1 by 2 and 1 by 2 would be at equal distance from 0. 1 by 2 and minus 1 by 2 would be at equal distance from 0. We know how to mark the rational number 1 by 2. It is marked at a point which is half the distance between 0 and 1. So minus 1 by 2 would be marked at a point half the distance. We know how to mark 3 by 2 on a number line. It is marked on the right of 0 and lies halfway between 1 and 2. Let us now mark minus 3 by 2 on the number line. It lies to the left of 0 and is at a distance of 3 by 2 from 0. In decreasing order, we have minus 1 by 2, minus 2 by 2, minus 1, that is minus 1, and minus 3 by 2, minus 4 by 2, minus 2. This shows that minus 3 by 2 lies between minus 1 and minus 2. Thus, minus 3 by 2 lies halfway between minus 1 and minus 2. Marks minus 5 by 2 and minus 7 by 2 in the similar way you can find out. Similarly, 1 by 3 is to the left of 0 and at the same distance 0 as 1 by 3 is to the right. So it's done above. Minus 1 by 3 can be represented on the number line. Once we know how to represent minus 1 by 3 on the number line, we can also represent minus 2 by 3, minus 4 by 3, minus 5 by 3, etc. and so on. All other rational numbers with different denominators can be represented in a similar way. Rational numbers in standard form. Observe the rational numbers 3 by 5, minus 5 by 8, 2 by 7, minus 7 by 11. The denominators of these rational numbers are positive integers and 1 is the only common factor between the numerators and denominators. Further, the negative sign occurs only in the numerator. Such rational numbers are said to be in standard form. Right? Such rational numbers are said to be in standard form. A rational number is said to be in standard form if its denominator is a positive integer and the numerator and denominator have no common factors other than 1. Right? If a rational number is not in the standard form, then it can be reduced to the standard form. Recall that for reducing fractions to their lowest form, we divide the numerator and denominator of the fraction by the same non-zero positive integer. We shall use the same method for reducing rational numbers to their standard form. Reduce minus 45 by 30 to the standard form. We have minus 45 by 30. If we divide by 3, we are getting minus 15 by 10. Or if we again divide it by 5, we are getting minus 3 by 2. We had to divide twice. First time by 3 and then by 5. This could also be done as divided by 15, that is minus 3 by 2. In this example, note that 15 is the HCF of 45 and 30. Thus, to reduce the rational numbers to its standard form, we divide the numerator and denominator by their HCF, ignoring the negative sign, if any. The reason for ignoring negative sign will be studied in higher classes. If there is a negative sign in the denominator, divide by minus HCF. Reduced to standard form, 36 by minus 24. The HCF of 36 and 24 is 12. Thus, its standard form would be obtained by dividing by minus 12, that is minus 3 by 2. The HCF of 3 and 15 is 3. We divided by minus 3 by minus 3 and 15 by minus 3, you will get 1 by 5. Right? Now, comparison of rational numbers. How to compare the rational number? Right? Comparison of rational numbers. We know how to compare two integers or two fractions and tell which is smaller or which is greater among them. Let us see how we compare two rational numbers. Two positive rational numbers like 2 by 3 and 5 by 7 can be compared as studied earlier in the case of fractions. Mary compared two negative rational numbers minus 1 by 2 and minus 1 by 5 using number line. She knows that integer which is on the right side of the other integer was the greater integer. For example, 5 is to the left of 2 on the number line and 5 is greater than 2. The integer minus 2 is on the right of minus 5, so minus 2 is greater than minus 5. She used this method for rational number also. She knew how to mark rational numbers on the number line. She marked minus 1 by 2 here and minus 1 by 5 here. Has she correctly marked the 2 points? How and why did she convert minus 1 by 2 to minus 5 by 10 and minus 1 by 5 to 2 by minus 2 by 10? Right? She found that minus 1 by 5 is to the right of minus 1 by 5. Minus 1 by 5 is to the right of minus 1 by 2. Thus, minus 1 by 5 is greater than minus 1 by 2. Or minus 1 by 2 is less than minus 1 by 5. Can we compare minus 3 by 4 and minus 2 by 3, minus 1 by 3 and minus 1 by 4? We know from our study of fractions that minus 5 is less than 1 by 2 and what Mary did get minus 2, 1 by 2 and minus 1 by 5. Was it not exactly the opposite? You will find that 1 by 2 is greater than 1 by 5 but minus 1 by 2 is less than minus 1 by 5. Do you observe the same for minus 3 by 4, minus 2 by 3, minus 1 by 3 or minus 1 by 5? Mary remembered that in integers she had studied 4 is greater than 3 but minus 4 is less than minus 3. 5 is greater than 2 but minus 5 is less than minus 2, etc. The case of pair of negative rational numbers is similar. To compare two negative rational numbers, we compare them ignoring the negative signs and then reverse the order. For example, to compare minus 7 by 5 and minus 5 by 3, we first compare 7 by 5 and 5 by 3. That is, we get 7 by 5 is less than 5 by 3 and conclude that minus 7 by 5 is greater than minus 5 by 3. Right? Take 5 more pairs and compare them. Comparison of a negative and a positive rational number is obvious. A negative rational number is to the left of 0, whereas a positive rational number is to the right of 0 on a number line. So a negative rational number will always be less than a positive rational number. That is, minus 2 by 7 is less than 1 by 2. To compare rational numbers minus 3 by 5 and minus 2 by 7, reduce them to their standard forms and then compare them. Do 4 by minus 9 and minus 16 by 36 represent the same rational number? Yes, because 4 by 9, if you multiply with minus 4, you are getting minus 36, 16 by 36, or minus 16 by 36 divided by minus 4, we are getting 4 by minus 9. Rational numbers between two rational numbers, right? Rational numbers between two rational numbers. Resma wanted to count the whole numbers between 3 and 10. From our earlier classes, she knew there would be exactly 6 whole numbers between 3 and 10. Similarly, she wanted to know the total number of integers between minus 3 and 3. The integers between minus 3 and 3 are minus 2, minus 1, 0, 1, 2. Thus, there are exactly 5 integers between minus 3 and 3. Are there any integers between minus 3 and minus 2? No, there is no integer between minus 3 and minus 2. Between two successive integers, the number of integers is 0. Between two successive integers, the number of integers is 0. Thus, we find that the number of integers between two integers are limited, finite. Will the same happen in the case of rational numbers also? Resma took two rational numbers minus 3 by 5 and minus 1 by 3. She converted them to rational numbers with its same denominators. This minus 3 by 5 is equal to minus 9 by 15 and minus 1 by 3 equal to minus 5 by 15. Now we know that minus 5 by 15 is less than minus 8 by 15, is less than minus 7 by 15, is less than minus 6 by 15, less than minus 5 by 15, right? Or minus 3 by 5 is less than minus 8 by 15 and less than minus 7 by 15, less than minus 6 by 15, less than minus 1 by 3. She could find rational numbers minus 8 by 15, that is less than minus 7 by 15 is less than minus 6 by 15 between minus 3 by 5 and minus 1 by 3. Are the numbers minus 8 by 15, minus 7 by 15, minus 6 by 15 the only rational numbers between minus 3 by 5 and minus 1 by 3? We have minus 18 by 30 is less than minus 3 by 5 and minus 5 by 8 by 15 is less than minus 16 by 30 and minus 18 by 30 is less than minus 17 by 30 and 17 by 30 is less than minus 16 by 30. That is, minus 3 by 5 is less than minus 17 by 10 and it is less than minus 8 by 15. Hence, minus 3 by 5, minus 17 by 30, minus 8 by 15, minus 7 by 15, minus 6 by 15, minus 1 by 3. This is less. So you can find one more rational numbers between minus 3 by 5 and minus 1 by 3. By using this method, you can insert as many rational numbers as you want between two different rational numbers. For example, minus 3 by 5 we can be written as minus 90 by 150 and minus 1 by 3 it can be written as minus 50 by 150. We get 39 rational numbers, that is minus 89 150 to minus 51 to 150, between minus 90 and 150 to minus 50 and 150, between minus 3 by 5 and minus 1 by 3. You'll find the list is unending. Can you list 5 rational numbers between minus 5 by 3 and minus 8 by 7? You can find unlimited number of rational numbers between any two rational numbers. You have to remember this one, that we can find unlimited number of rational numbers between any two rational numbers. Here you see, list 3 rational numbers between minus 2 and 1. Let us write minus 1 and minus 2 as rational numbers with denominator 5. For example, minus 1 equal to minus 5 by 5 and minus 2 equal to minus 10 by 5. Therefore, minus 10 by 5 is less than minus 9 by 5, minus 9 by 5 is less than minus 8 by 5, minus 8 by 5 is less than minus 7 by 5, minus 7 by 5 is less than minus 6 by 5, and minus 6 by 5 is less than minus 5 by 5. Right? Then we are getting that minus 2 Between minus 2 and minus 1, there is minus 9 by 5, minus 8 by 5, minus 7 by 5, minus 6 by 5. The three rational numbers between minus 2 and minus 1 would be minus 9 by 5, minus 8 by 5, minus 7 by 5. You can take any three of minus 9 by 5, minus 8 by 7, 5, or minus 7 by 5, or minus 6 by 5. Write four more numbers in the following pattern: minus 1 by 3, minus 2 by 6, minus 3 by 9, minus 4 by 12, minus 2 by 6. If you multiply, it can be written as minus 1 by 1 into 2, or 3 into 2, that is minus 3 by 9. Minus 1 by 3, minus 1 into 3, or 3 into 3, that is minus 4 by 12, right? Minus 4 by 12 is equal to minus 1 into 4 by 3 into 4, or minus 1 into 1 by 3 into 1 is equal to 1 minus 1 by 3, or minus 1 into 2 equal to 3 into 2, that is minus 2 by 6, right? Minus 1 into 3 into 3 by 3, minus 3 by 10, minus 1 into 4 by 3 into 4, that is minus 4 by 12. Thus, you observe a pattern in these numbers. What is that? The other numbers would be minus 1 into 5, and 3 into 5 is minus 5 by 15, minus 1 into 6, that is by 3 into 6, that is minus 6 by 18, and minus 1 into 7, minus 7 by 21, right? Now we will, in the next video, we will learn the different exercises of rational numbers. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.